Hi everyone, in this video I'm going to solve O-Levels Additional Mathematics Paper 1 in a session October-November 2022 Paper 1-3. So let's start with the first question. Question number 1, on the axis sketch the graph of y equals to 4 sine 3x minus 2 for x lies between minus pi by 3 to plus pi by 3. Okay, so let me graph this by using the table of values. So we have the x values minus pi by 3, minus pi by 6, 0, pi by 6 and pi by 3, and we can find the corresponding y values. Okay, so let me fix the table for x and for y. So if the x values is minus pi by 3, what is the y value? So let me write down the function, which is y equals to 4 sine 3x minus 2, right? Okay, so 4 sine 3 times negative, it should be in radians, yes, pi by 3 minus 2, which is negative 2, at minus pi by 6, which is minus 6, at 0, minus 2, next point is pi by 6, it's 2, and the last is pi by 3. Minus 2. Okay, so now let me plot all the points. At minus pi by 3 it is negative 2, minus pi by 6 negative 6, 0 it's minus 2, and pi by 6 it's plus 2, and pi by 3 it's negative 2. It's a sinusoidal curve, and its equation of axis is minus 2, and the amplitude should be 4. Okay, so let me connect all the points to get the smooth curve for this sinusoidal function. Right. So this is a sketch for the given sine function. Question number 2, part A, show that 2x squared plus x minus 15 can be written in the form of this, where a and b are exact constants to be found. This is a standard form of quadratic equation, and this is a vertex form. Okay, so let me convert the standard to vertex form. The first step is to take the coefficient of x squared common, which is 2x squared plus x over 2 from first and second term, and the constant term stays the same, right? Okay, and the next step we have to do x squared plus x over 2. Okay, now we have to take the coefficient of x, which is 1 by 2, divide it by 2 and take its whole square, right? So 1 by 2 divided by 2 and its square is 1 by 16. So we have to add and subtract inside the bracket and subtract 1 over 16, right? Now in the next step, let me combine the first three terms. It's minus 15 is as it is. X squared plus x over 2 plus 1 over 16 minus 15 is as it is, and minus 2 over 16. Okay, now let's complete the square. We have 2. Here x squared, 1 over 4 squared. So this is x plus 1 over 4 whole square. And simplify this term. Minus 2 over 16 minus 15, which is minus 121 over 8. Right. So the a value is 1 by 4 and the b value is minus 121 over 8. right? Now for part B, hence write down the coordinates of the stationary points on the curve. So stationary points are basically the turning points, or for quadratic, the turning point is basically the vertex point, right? So the vertex point is 1 by negative 1 by 4 and negative 121 by 8. If we can write it in vertex form, we have a quadratic equation a into x minus h whole square plus k. H and k are the vertex. So here if we compare this, h is minus 1 by 4 and k is minus 121 by 8. So the coordinates of the turning points or the stationary points are minus 1 by 4 and minus 121 out of 8, right? Now for part C, on the axis sketch the graph of absolute of this function, stating the coordinates of the points where the graph meets the coordinate axis. Basically, let's find the x and the y intercepts, right? Okay, so let me find the x-intercept first. For x-intercept, put y equals to 0. This y would be equals to 0, and we have 2x square plus x minus 15. This would be equals to 0, right? So this is a quadratic equation. We have to find the two roots. 2 times of 15, which is negative 30, and we have to break the midterm. We can say 5 times 6 is 30, and 6 minus 5 is 1. 2x square plus 6x minus 5x minus 15 would be equals to 0. 2x is common, x plus 3 minus 5 is common, x plus 3, this is equals to 0. X plus 3 and 2x minus 5, this is equals to 0. So x is equals to negative 3 and x is equals to 5 by 2, right? So what is 5 by 2, which is 2.5. Now let me work on y-intercept. For y-intercept, let me put x is equals to 0 throughout the equation. So y equals to negative of 15 is my y-intercept. So we have to take the absolute. So y equals to 15. 15 is the y-intercept, minus 3 and 2.5 are the x-intercept. So let me graph this. Since it is the absolute value function, and inside the absolute it is a quadratic, so it should be a parabola. Let me scale this. This is 1, 2, 3. This is negative 1, negative 2, and negative 3. And for y, 5, 10, and 15. 15, negative 3 to 2.5 in the middle, right? So negative 3, 15, and 2.5. These two are the x-intercept and the y-intercept. So let me draw the parabola, and for absolute, it should be look like this. Okay. This is a sketch for the given absolute value function. Now for part D, write down the value of the constant k for which the equation this equals to k has 3 distinct solutions. Okay, so it has 3 distinct solutions. When it has 3 distinct solutions, right? So basically y equals to k, just substitute this y equals to k. Okay, y equals to k is just a straight horizontal line. So if I draw the line at y equals to 0, so it has 2 solutions, and if I draw the line at y equals to 1 or more, so it has 1, 2, 3, 4 solutions, right? But if I drew the line over here, it touched the vertex, it has exactly three solutions, right? This solution, the vertex, and this solution. So y equals to this is a vertex point, and we have the vertex point which is minus 121 over 8. Since it is the absolute, so we have to take positive 121 over 8. This is the line. So we can say that the value of the constant k for which the equation has three distinct solutions is k equals to positive over 121 over 8. Question number 3, part A. Solve the following simultaneous equations. Okay, so if I can say from the second equation, let me solve for x. X is 1 by 2y. Substitute over here. So 3y minus 2 times of x is 1 by 2y plus 2. This is equals to 0. 2 is cancelled with 2. We have 3y minus 1 over y plus 2 equals to 0. Now taking y as an LCM, or we can just multiply throughout the equation by y. So we have 3y square minus 1 plus 2y. This is equals to 0, or 3y square plus 2y minus 1 equals to 0, right? Now this is a quadratic equation and a variable y. So if I can factorize this equation, we have 3 times minus 1 and the factors are 2. So 3 minus 1 is 2. Yes, 3y square plus 3y minus y minus 1 equals to 0. So 3y is common, y plus 1, minus 1 is common, y plus 1 equals to 0, right? The two factors are y plus 1 and 3y minus 1 equals to 0, right? So from here we have two values for y equals to negative 1, right? And y is equals to positive 1 over 3, right? Now let me solve the corresponding x value. Right, now we have the equation for x is equals to 1 by 2y. So when at y is equals to negative 1, what is my x value? X is equals to 1 by 2 times negative 1, which is minus 1 by 2, right? When y is equals to 1 by 3, what is x? X is 1 by 2 into 1 by 3, which is 1 over 2 by 3, which is 3 by 2, right? Now we have two solutions for x and y. X is minus 1 by 2 when y is minus 1. This is the first solution. And x is 3 by 2 when y is 1 by 3. Right. Now for this part B, solve the equation giving your answer as a power of 3. Let me use a change of base over here. So we have log 3x plus 3 equals to 10 log 3 over log x with the base 3. Now log base 3 is just 1. Log 3x plus 3 equals to 10 over log 3x, right? Now let me multiply both sides of the equation by log base 3x. Log base 3x its whole square plus 3 times of log base 3x equals to 10, right? Now shift this 10 on the other side. We have log base 3x whole square plus 3 log base 3x minus 10 equals to 0. This look like a quadratic, so in log 3x. So let me factorize this. 1 times minus 10 is minus 10, 2 times 5, and 5 minus 2 is 3. log 3x whole square plus 5 log 3x minus 2 log 3x minus 10 equals to 0. Right. Now let me take log 3x common. We are left with log 3x plus 5. Let me take minus 2 common, log 3x plus 5. The two factors are log 3x plus 5 and log 3x minus 2 equals to 0. Right. Now let me find the two values for x. Let me put both the factors separately equals to 0. So from the first factor we have log 3x equals to minus 5, and from second factor log 3x equals to 2. So from here x equals to 3 power minus 5, and from here x is equals to 3 power 2. So these are the two solutions for x as a power of 3. Question number 4. The polynomial p of x is such that we have given p of x where a, b and c are integers. It is given that p prime of 0 is minus 9. Part A show that b value is minus 9. So let me take the derivative p prime of x, which is 3ax square plus 2 times 13, 26 x plus b, and its derivative is 0. Now what is p prime of 0? When x is 0, this term is 0, this term is 0, we have just b, and p prime of 0 is basically equals to 9 minus 9. So from here b value is minus 9, right? Okay, now it is also given that 3x plus 2 is a factor of p of x. If it is a factor, it means p of minus 2 by 3, this would be equals to 0. And that when p of x is divided by x plus 1, the remainder is 6. The remainder is 6. It means that p of minus 1 is 6. So we have two information. Okay, now for part B, find the value of a and c. So by using these two information, we can easily find a and c value, right? Okay, now we have the polynomial p of x is equals to ax cube plus 13x square plus bx, b is minus 9x plus c, right? Using the first condition, we have p of minus 1 is equals to 6. Over here I'm using this one. Okay, so a minus 1 cube plus 13 minus 1 square minus 9 times minus 1 plus c would be equals to 6. Minus a plus 13 plus 9 plus c equals to 6. So now we have minus a plus c equals to 6 minus 13 plus 9 is 22. 6 minus 22 is minus 16. Or a minus c is 16. This is my first equation. Okay, now by the second condition, we can say p of 2 by 3 minus 2 by 3 would be equals to 0 because it is a factor. Right. So a times minus 2 by 3 whole cube plus 13 times minus 2 by 3 whole square minus 9 times minus 2 by 3 plus c, this would be equals to 0. So this is a minus 8 over 3 cube is 27 plus 2 by 3 square times 13 is 52 over 9 plus 2 times 9 is 18 over 3 plus c equals to 0, right? Now with a, we have minus 8 over 27a plus c, and the two constant terms are 52 over 9 plus 18 over 3. 106 over 9, right? Okay, so if I consider this as my second equation, right, now we have two equations. A minus c is 16 and this one. So if I can add the two equations, yes. Okay, so let me add the two equations. We have a minus c, this is 16, right? Sorry, yeah, positive 16, and minus 8 over 27a plus c is minus 106 over 9, shifting this on the other side, right? So if I add the two equations, you can see we can easily cancel the c, positive c and negative c, right? So let me add these two terms. Minus 8 over 27 plus 1, 19 over 27a equals minus 106 over 9 plus 16, 38 over 9. Now what is a? 38 over 9 times 27 over 19, right? Okay, is times 27 over 19. This is equals to 6. So a value is 6. Now let me substitute this into my first equation to get the c value. So put a equals to 6 in equation 1. Equation 1 is simple. So we have a minus c would be 16. So 6 minus c is 16. 6 minus 16 equals to c. Shifting 16 is negative and c on the other side. So 6 minus 16 is minus 10. This is the c value. C is minus 10 and the a value is positive 6. Now let me rewrite the polynomial p of x. A value is 6. X cube plus 13x square. B is minus 9x and the c is negative 10. Right. Now for part C, find the quadratic q of x where p of x is 3x plus 2 times p of x, right? This is a cubic polynomial. We have to convert into linear and a quadratic one. So if I can do the synthetic division, and we know that one factor of this one, let me apply the synthetic division method here and we can find the quadratic factor. Okay, so the coefficient for x cube, x square, x and the constant. This is a factor, so what is x? X is minus 2 by 3. 6 is as it is. Okay, so minus 2 by 3 times by 6, this is negative 4. Add in 13, which is 9. Okay, 9 times minus 2 by 3, which is minus 6. And minus 9, which is minus 15. Minus 15 times minus 2 by 3, which is 10. And here we have 0. So these are the coefficients for the quadratic factor, right? So let me rewrite. P of x is equals to 3x plus 2. And the quadratic factor is 6x square plus 9x minus 15, right? Sorry, this is basically x and plus 2 by 3, right? This is a factor, and let me take 3 common. We have 3 times 2 is 6, 3 times 3 is 9, and 3 times 5 is 15, right? Okay, so multiply 3 with here, so 3x plus 3 cancel with 3, we have 2, and the other one is 2x square plus 9x minus 5. We got the exactly same thing, right? Now for part D, hence find p of x as a product of linear factors with integer coefficients. Okay, so we have p of x equals to 3x plus 2 and this factor. So 2 times 5 is 10, 1 times 10 is 10, and 10 minus 1 is 9. 2x square plus 10x minus x minus 5. So 3x plus 2. Let me take 2x common. We have x plus 5. Minus 1 is common, x plus 5. So the product of three linear factors are 3x plus 2, x plus 5, and 2x minus 1. Question number 5. A geometric progression is such that the 15th term, a15, is equals to 1 by 8 of the 12th term, a12. Right, so it is a geometric progression. Number of term number is an, is a r power n minus 1. That is a formula, right? The sum to infinity is equals to 5. S infinity we have given. Part A, find the first term and the common ratio, right? If I use these conditions, what is a15? A15 is first term, r power 15 minus 1, which is 14. This is equals to 1 by 8 of the 12th term, a r power 11. Right, okay, so from here we can cancel a, and we can say that 14 and 11, so 14 minus 11 is 3. Yes, so r cube is 1 over 8, right? What is r? R is 1 by 2, because 8 is a cube of 2, right? So we got the value for r. By using the second condition, the sum to infinity, we can easily find the a value, right? Okay, s infinity, the formula for s infinity is a over 1 minus r. This is equals to 5. So a over 1 minus 1 by 2, this is equals to 5. What is 1 minus 1 by 2? 1 by 2. So a value is 5 times 1 by 2, right? So from here the a is 5 by 2. So the first term is 5 by 2 and the common ratio is 1 by 2. Now for part B, find the least number of terms. We have to find the n value needed for the sum of the geometric progression to be greater than 4.999. Okay, sum of geometric progression, its formula is Sn equals to a into 1 minus r power n over 1 minus r, right? Now we have a and r, just substitute into the formula. A is 5 by 2 into 1 minus r is 1 by 2, its power is n, whole divides 1 minus r, 1 minus 1 by 2, is greater than 4.999, right? Further simplification, 1 minus 1 by 2 we already did. This is 1 by 2 and it is times by 4.999, which is 2.4995. So we have 5 by 2 into 1 minus 1 by 2, its whole power n is greater than 2.4995, right? Now we have to solve for n. We have 5 by 2, do the reciprocal, which is 2 by 5. So times this by 2 by 5, which is 0.9998. 1 minus 1 by 2, its whole power n is greater than 0.9998, right? Okay, now minus 1 by 2 whole power n is greater than, shifting minus 1 on the other side, which is equals to minus 2 times 10 power minus 4. Okay, Okay, let me cancel with the negative signs. This is 0.5 whole power n is greater than 2 times 10 power minus 4. Now to solve for n, we have to take log on both sides. N times log of 0.5 is greater than log of 2 times 10 power minus 4. Right. Now for further simplification, if I can do over here, what is n? So we have n is greater than log of 2 times 10 power minus 4 divides log of 0.5. Okay, now let me calculate this. Log 2 times 10 power negative 4 divides log 0.5. So n should be greater than 12.29. So we can say that we need to find the least number of terms. So n is equals to 13, which is greater than 12.29. Question number 6. A function f of x is such that we have an exponential function for x belongs to real number. That is the domain. Now for part A, find the range of the function. So x belongs to real numbers. So in real numbers are lying between minus infinity to plus infinity. Let me check the function value at infinity and minus infinity. So if I can do what is f of infinity, which is e power infinity minus 4 infinity, which is infinity, and f of minus infinity, e power minus infinity minus 4, which is 1 over e power infinity, which is 0, 1 over e power infinity minus 4, which is equals to something, or this is e power infinity minus 4, something by infinity is 0, 0 minus 4 is minus 4, right? So if the domain lies between minus infinity to plus infinity, so at the outputs are infinity and minus 4. It means the y values are from minus 4 up to infinity. So from here we can easily guess that the range of f of x is greater than minus 4, means minus 4 up to infinity. Now for part B, find an expression for f inverse of x. So we can say y is a function of f of x, which is e power 3x minus 4. X is equals to e power 3y minus 4. Right, and now let me solve for y. Right, so x plus 4 is equals to e power 3y. Right, now for this let me take ln on both sides. Ln of x plus 4 is equals to 3y, and from here y is equals to 1 over 3 ln of x plus 4. Right, and this is my f inverse of x. Okay, now for part C, on the axis sketch the graph of y equals to f of x and y equals to f inverse of x, stating the exact values of the intercepts with the coordinate axis. Right, let me start with f of x. Right, we have a function f of x e power 3x minus 4. We have to find the intercepts with the coordinate axis, the x and the y intercepts first. Right, okay, so let me find the x-intercept. For x-intercept, put y equals to 0 or f of x equals to 0. E power 3x minus 4, this is equals to 0. So e power 3x would be equals to 4. And we can say that 3x is equals to ln of 4. And x is equals to 1 by 3 ln of 4. This is my x-intercept. If I calculate this, ln of 4 divided by 3, 0.462. 0.462. Right, now let me solve the y-intercept, the other side, for the same function. Okay, y-intercept, we have to put x equals to 0, so y is equals to e power 0 minus 4. E power 0 is 1, 1 minus 4, so y is minus 3. This is for f of x, and we know that for f inverse of x we have to switch the intercepts, right? So if I have f inverse of x, which is equals to 1 by 3 ln of x plus 4, right? My x intercept is this is my x-intercept, which is negative 3, and my y-intercept is y is equals to 1 by 3 ln of 4. Right, now let me sketch the x and the y-intercept for the function and the inverse function, right? Okay, now let me fix for centimeter. Okay, this is 1 2 3, and here we have minus 1 minus 2 minus 3. X-intercept is minus 3 and the y is the same. For y-intercept we have 1 2 3 and minus 1 minus 2 and minus 3, right? Okay, now for accuracy I select the scale with 0.5, right? Now for my function f of x, my x inverse is 0.46, which is closer to 0.5, and my y-intercept is negative 3, which is downward. 0.5 minus 0.5 minus 1, 1 point minus 1.5 minus 2 minus 2.5 and minus 3 is over here, right? These are my x and the y-intercepts, x-intercept and the y-intercept. Let me connect the x and the y-intercept. Okay, now for f inverse of x, my x-intercept is negative 3 over here, and the y-intercept is 0.4, closer to 0.5 over here, right? Now let me connect these two intercepts. Yes, okay, so this is a graph for the in f of x and f inverse of x. This is for f of x, right, and this is for f inverse of x on the same set of x's. Question number 7, find the exact value of this integral. It's a definite integral, so we have to do the integration for all the functions. The integration of cos 3x is sine 3x over 3 plus 4. The integration of sine 2x is minus cos 2x over 2, and the integration of 1 is just x. The lower limit is 0 to pi by 2, right? Okay, further simplification, we have 1 by 3 sine 2x, sine 3x minus 2 cos 2x plus x from 0 to pi by 2. Okay, now let me substitute the limits. The upper limit is pi by 2, 1 by 3 sine 3 pi by 2 minus 2 cos 2 pi by 2 plus pi by 2. Subtract the lower limit, which is 0, so 1 by 2, 1 by 3 sine 0 minus 2 cos 0 plus 0, right? So 1 out of 3 Let me simplify in terms of radians. My calculator is in radians. So what is sine 3 pi over 2? Yes, minus 1, minus 2, cancel, cos pi, minus 1, plus pi by 2, minus, what is sine 0? This is 0, cos 0 is 1, so minus 2 plus 0. Okay, further simplification, we have minus 1 by 3 plus 2 plus pi by 2. Negative times negative is positive of 2, right? Okay, so we have 2 plus 2 is 4 and minus 1 by 3, which is 11 by 3, and plus pi by 2. This is the exact value of this integral. Question number 8. In this question, all lengths are in meters. The diagram shows a circle. Center O, radius is 7. OA, OB, and O to this point it is 7. The point A and B lies on the circumference of the circle. The line BC is tangent to the circle at B such that the length of BC is 24 meters. The length of the minor arc AB is 12.25. Part A, find the obtuse angle AOB. AOB. This is the obtuse angle, more than 90, giving your answer in radians. Okay, so we have given the radius and the arc length. We can find the angle. So since arc length is radius times theta, S is the arc length, so we can say the arc length we have given is 12.25. Radius we have given is 7 times theta. So what is the value of theta? Theta is 12.25 divided by 7. 12.25 divided by 7, which is 1.75 radians. So this angle is 1.75 radians. Okay, now for part B, find the parameter of the shaded region. Okay, the parameter of the shaded region is OA, AB, BO, and this one. If I can say this is X, the shaded, just the parameter of the shaded region we have to find out. Okay, so this portion is shaded, right? So we know that A to this O is 7, O to this point is also 7, so this is 7, this is 12.25. What is B to X? We need to find this side. Okay, let me consider this triangle O, B, and C. We know that this is BC's tangent. Tangent is always perpendicular to the radius of a circle, so this is a right angle triangle, right? And OB is also 7. Okay, we have to find this angle. Okay, so if, let me draw this separately over here for clear understanding. If I have this triangle, okay, yes, this is my B is the vertical 90-degree angle, and then we have O, and this is C, and we have given that this is 7 meters and this is 24 meters, right? And we have to find this angle, so the front and the adjacent side we have given, right? So we can use a ratio for tangent because it is a right angle triangle. We can use the ratios, so we can say tan of theta, let's say this is theta, is opposite is 24 and adjacent is 7. So what is the value for theta? Theta is tangent inverse of 24 over 7, right? Let me calculate in terms of radians. Tangent inverse 24 divides 7, which is 1.287 or 1.289, 1.29 we can say if I round it, right? So we got this value for theta, 1.29. Okay, now we have this angle and the radius. We can find the arc length bx, right? So what is arc length? Arc length bx is radius times theta. Radius is 7 and theta is 1.29. So times this by 7, which is 9.0019. So 9.01 meters. Right. Now let me find the parameter by adding all the shaded sides. Okay, so as you can see, the shaded side is A, O, and this X. 7 plus 7, BX, and AB. Right, so we can say 7 plus 7 plus 9.01 plus 12.25. Right. Okay, in this we add 14. 7 plus 7 is 14 plus 12.25, which is 35.25. 9 or 35.3 meters is the parameter. Right. Now for part C, find the area of the shaded region. So this is a shaded region. We have to find its area. So basically we have to find the area of this sector and area of this sector, and we can add both of them, right? Okay, so since we have given we have both angles and the radius, so we can easily find the area of two sectors, right? So we can say that the shaded area is sum of areas of two sectors. So area of a sector is half radius square times theta. So the radius is 7 and theta is 1.75. So we can say 7 square times 1.75 plus 1 by 2. Radius is again 7 and the angle for the other arc is 1.29. 7 square into 1.29. Let me calculate this. We have 0.5 times 7 times 7 times 1.75, 42.875 plus 0.5 times 7 times 7 times 1.29, 31.605. Add in 42.875, which is 74.48, 74.5 meter scale, the shaded area. Question number 9. A 6-character password is to be formed from the following characters. So it should be a 6-character password: letters, numbers, and symbols. There are 4 letters, 4 numbers, and 4 symbols. No character may be used more than once in any password. It's a permutation question, no repetition. Question, part A1, find the number of different 6-character passwords that can be found. So it should be a 6-character: 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 options, and then 11 options, and then 10, 9, 8, and 7. Okay. 12 times 11 times 10 times 9 times 8 times 7, which is 665280. Right. Now for the second part, how many of these 6-character passwords ends with a symbol? So it's 6-character again: 1, 2, 3, 4, 5, 6. It ends with the symbols. We have 4 symbols here, 4 options for the last digit, right? Yes, it's only ending. There is a restriction on ending, right? So if we use one of the character, let's say one symbol we have used, steric, how many are left? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 are left, and then 10, 9, 8, 7. Right. 11 times 10 times 9 times 8 times 7 times 4. 221760. Right. Now for part B, find the number of different 6-character password that include all the symbols but do not start or end with the symbol. Right. So 1, 2, 3, 4, 5, 6. So it include all the symbols: asterisk, hash, $sign, and the pound sign. Right. So we have 4 options here, 3 options, 2 options, and 1 options, right? But they do not start or end with a symbol. The starting or ending can be a letter or can be a number. So 4 letters, 4 numbers. So we have 8 options for the first digit, and then if I used A, then 7 options are left for the last digit, right? Okay, so let me calculate. 8 times 4 times 3 times 2 times 1 times 7. 1344, 1344. Right. Question number 10, solve the equation where x is in radians, x lies between minus 1.5 to 1.5. Okay. So if I can rewrite this equation as square root of 2 over 2, this is equals to sine of 3x plus 1.2 over cos of 3x plus 1.2. Sine over cos is basically tangent of 3x plus 1.2. Okay. 1 over, this is equals to 1 over square root of 2. Okay, now let me simplify this. So from here we can say 3x plus 1.2. This would be equals to tangent inverse of 1 over square root of 2. It is in radians. So tangent inverse of 1 divides square root of 2. 0.6154. Okay, 0.615. Okay, so this is 3x plus 1.2. Okay, now here the tangent is positive. Now we have to check that tangent is positive in which quadrant. So if I use the cast rule, drawing the coordinates, okay, we have C, A, S, T. So tangent is positive in the first and in the third quadrant. So first quadrant we have theta, and third quadrant we do pi plus theta, right? So for the third quadrant we have the value 3x plus 1.2, which is equals to pi plus this value, right? So we can say 0.615 plus pi, the 3.75. Okay, now since 1.2 add over here, so we need to add and subtract 2 pi in these values, right? Okay, now let me add 2 pi, we will get 2 more answers, and subtract 2 pi, we will get 2 more answers, right? If I suppose this is a value for theta, and theta is 3x plus 1.2. Okay, so in 0.67 615, add 2 pi, which is 6.898, and let me subtract 2 pi, minus 5.668. Now for the other 3.75, add 2 pi, 10.033, and when I subtract 2 pi, minus 2.533, right? Okay, so we have 1 2 3 4 5 6 values for theta. So let me solve for x. So theta is 3x plus 1.2, theta minus 1.2, and divided by 3 we will get x. Right, now let me solve for x, and keep in mind the domain of x is between 1 minus 1.5 and plus 1.5. Okay, so the first value, let me start with the first one, 0.6 0.615 minus 1.2 divided by 3, 0.195. Yes, this belongs to the domain. Okay, 3.75 minus 1.2 divided by 3, 0.85 belongs to the domain. Okay, this is the next one. 6.898 minus 1.2 divided by 3, 1.899. No, it's not belongs to the domain. 10.033 minus 1.2 divided by 3, again 2.9 does not belongs to the domain. Minus 5.668 minus 1.2 divided by 3, minus 2.89. No. Minus 2.533 minus 1.2 divided by 3, minus 1.24. Yes, this belongs to the domain. So these are the three solutions for the given equation. Question number 11, it is given that this integral equals to ln 1 by 5 where a is greater than 1. Find the exact value of a. Okay, let me start from the left hand side. Okay, left hand side we have 1 to a 3 over 3x plus 2 with respect to dx, minus 1 to a 2 over 2x plus 1 with respect to dx, minus 1 to a 1 over x dx. Okay, so we have to, the derivative is complete in the numerator, so its integration is ln of 3x plus 2 minus its integration is ln of 2x plus 1. Its derivative is completed, and this is ln of x. No need to add constant of integration. This is a definite integral, so we need to substitute the upper and the lower limit. Ln of 3a plus 2 minus ln of 2a plus 1 minus ln of a. This is my upper limit. Subtract the lower limit. Ln of 3 times 1 plus 2, 5, minus ln of 2 times 1 plus 1, which is 3, minus ln of 1. Ln of 1 is just 0. So this is ln of 3a plus 2 minus ln of 2a plus 1 minus ln of a, minus this is ln of 5 minus ln of 3. Ln of 1 is just 0, right? Now let me apply the logarithmic properties here. So this is in division, this is addition, and this is in division, so we can say ln of 3a plus 2 is going to divide with 2a plus 1, right? And this is also in division, so you have to times by a, minus ln of 5 by 3. This is my left hand side, right? Now let me put this left hand side equals to the right hand side, right? Okay, let me do one more step, right? Again, it is in division, a subtraction, so we can divide ln of 3a plus 2 over a times 2a plus 1. This is going to divide with 5 over 3 or times by 3 by 5. Okay, now this would be equals to my right hand side. From here we can say ln of 3 times 3a plus 2 over 5a times 2a plus 1. This is equals to ln of 1 over 5, right? For the simplification, we can cancel the ln on both sides. We have to solve for a, and it should be greater than 1. 9a plus 6 over 5 times 2 is 10a square plus 5a. This would be equals to 1 over 5. Let's do the cross multiplication. 9 times 5 is 45a. 5 times 6 is 30. This is equals to 10a square plus 5a. Okay, now shifting the terms. Okay, taking all the terms on the right. 10a square plus 5a minus 45a minus 30. 10a square minus 40a minus 30. 0 equals to, okay, so let me divide by 10. So a square minus 4a minus 3. Right, so this is a quadratic equation in a, so we can solve this equation to get the value of a. The quadratic equation is a square minus 4a minus 3 equals to 0. Apply the quadratic formula. A would be equals to negative of 4 plus minus square root minus 4 whole square minus 4, 1 and minus 3 divides the square root 2 times of 1. A would be equals to 4 plus minus square root. We have 16 plus 12 divides 2. 16 plus 12, 28. A would be equals to 4 plus minus square root of 28 divides 2. Okay, square root of 28 is 2 square root of 7. So a is equals to 4 plus minus 2 square root of 7 divided by 2. If I take 2 common, so we have a would be equals to 2 is common. 2 plus minus square root of 7 divided by 2. We can cancel the 2. So a would be equals to 2 plus minus square root of 7. And on a, we have a restriction that a should be greater than 1. So we can check on which value it is greater than 1, right? 2 plus square root of 7 is more than 1. Yes. What is 2 minus square root of 7? This is less than 1, right? So we can say a is equals to 2 plus square root of 7. This is greater than 1. This is the exact value for a. Question number 12, it is given that y equals to this for x is greater than 1. Part A, write dy by dx in the form this where a and b are integers. Okay. We have given y, so we have to differentiate this. Dy over dx is, we need to apply the quotient rule here. So for quotient rule, we have to do x minus 1 and the derivative of the numerator function, which is power rule, 2 by 3, 3x square minus 2, its power is 2 by 3 minus 1, minus 1 by 3, and the derivative of 3x square, which is 2 times 3 is 6x, minus the numerator function and the denominator function derivative is just 1, right? Okay, this is going to divide with the square of the denominator function, x minus 1 whole square. 3 times 1 is 3, 3 times 2 would be 6. Okay, further simplification, x minus 1 times 2 times 2 is 4x into 3x square minus 2 times minus 1 by 2 minus 3x square minus 2, its power is 2 by 3, and this is going to divide with x minus 1 whole square, right? So we have to write the derivative in this form. So x minus 1 whole square, and we have to take 3x square minus 2 power minus 1 by 3 common. Sorry, this is minus 1 by 3. So let's do this. 3x square minus 2, its power is minus 1 by 3 is common, and from the denominator we have x minus 1 whole square. What is left inside? So we are left with 4x times x minus 1 over here, minus, and if we took divide it, yes, 2 by 3 this, and add 1 by 3, so its power is just 1. So 3x square minus 2. This would be a quadratic expression. Let me simplify that expression. So this term stays the same. 4x square minus 4x minus 3x square plus 2, right? One more steps. 3x square minus 2 okay, so we have x square minus 4x plus 2. This is a quadratic expression. So a and b are minus 4 and 2. Now for part B, find the approximate increase in y as x increases from 2 to 2 plus p, where p is small. So basically we have to find dy over dx at x is equals to 2 and times our answer by p, right? So when x is 2, what is the answer? Let me simplify. 2 square is 4, 3 times 4 minus 2, and its power is minus 1 by 3. Okay, divide 2 minus 1 is 1, 1 square is just 1, right? Divided by 1, and times by 2 square is 4 minus 4 times 2, which is 8, plus 2, minus 0.928 times p. Question number 13. The points P and Q have coordinates this and this respectively. The point R lies on a line L, which is the perpendicular bisector of line PQ. The x coordinate of R is 7, number A. Find the y coordinate of R. Okay, so first we have to find the equation of line L, which is the perpendicular bisector of the line PQ. Right, so to find the perpendicular bisector, first thing is we need to find the midpoint of PQ. Midpoint of PQ is 5 plus 15 by 2 and minus 12 minus 6 by 2. Okay, 5 plus 15 divided by 2 is 10. And minus 12 minus 6 divided by 2 is minus 9. Negative of 9. Right. The next thing we need is the slope of PQ. Okay. y2 minus y1 over x2 minus x1. Okay, 12 minus 6 is 6, and 15 take away 5 is just 10. And what is 6 out of 10? 3 by 5. Now from here the slope of line L is the perpendicular negative reciprocal of this negative, and the reciprocal is 5 by 3. Okay, let me find the equation of line L. Y minus y naught, which is plus 9, equals to the slope minus 5 over 3 into x minus x naught, which is 10. This is x naught, y naught, and this is the m value. This is the equation of line L, right? Now x coordinate is 7. We can find the y coordinate. When x is 7, just substitute x equals to 7. We can find y. So y plus 9 would be equals to minus 5 by 3 into 7 minus 10. Okay, 7 minus 10 times minus 5 by 3, which is 5. So y equals to 5 minus 9, which is negative 4. So the y coordinate is negative 4. So we can say that the coordinates for point R, x is 7 and the y is negative 4, right? Now for part B, the point S lies on L. So if it lies on L, so it must satisfy the equation of line L such that its distance from PQ is 3 times the distance of R from PQ. So here we have to consider the midpoint of PQ, which we got from the first step, first part, that is 10 minus 9. Find the coordinates of two possible positions of S. Okay, so the distance of S from PQ, so the distance S is let's say xy, and the midpoint of PQ is, we have 10 minus 9 and R is 7 minus 4. Okay, the distance of S from PQ is 3 times the distance of R from PQ. So here we have to use the distance formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square. So we can say that the distance of S from PQ, S to the midpoint, this is 3 times the distance of R to the midpoint, right? So using the distance formula, we have a square root of x2 minus x1 whole square, so x minus 10 whole square plus y plus 9 whole square. This would be equals to 3 times square root and PQ and R. Okay, so we have 10 minus 7 whole square plus minus 9, this is minus 9 minus 4 is plus 4 whole square. Okay, now we can easily cancel the square roots on both sides by taking a square, right? So we can say squaring on both sides. So there we have x minus 10 whole square plus y plus 9 whole square. 3 square is 9. Okay, and we have 10 minus 7 is 3 square plus 9, take away 4 is minus 5 whole square. Okay, let me simplify this side. 3 square is 9, 5 square is 25 times by 9, x minus 10 whole square plus y plus 9 whole square, this is 306, right? So from the first equation, we have the line L. This is my line L. We have y plus 9 value. Let me substitute that value over here. So x minus 10 whole square plus y plus 9 values minus 5 by 3, x minus 10 and its whole square. This is equals to 306. Okay, now x minus 10 whole square, 5 square is 25, 3 square is 9, and x minus 10 whole square, this is 306, right? Further simplification, let me take x minus 10 whole square common. Here we are left with 1 plus 25 over 9, and this is equals to 306, right? So what is x minus 10 whole square? 306 times 9 over 25 over 9 plus 1, 34 over 9, so 9 over 34 we can say, right? So we can take 34 over here, which is x square, minus 2 times 10 is 20x, and 10 times 10 is 100. This is 306 times 9, 2754. So this is 34x square. 34 times 20 is minus 680 x plus 3400 and minus 2754. This is equals to 0. 34x square minus 680x. Okay, so 3400 minus 2754. 646 positive. Okay, now this is a quadratic equation in x. We will get the 2x values. Okay, so if I can solve it by using factorization or quadratic formula. Okay, let's do it by formula. Okay, so x is equals to negative of b value, which is 680, plus minus square root b square. 680 square is 46400 minus 4ac. Okay, minus 87856. Okay, this is going to divide with 2 times of a. 2 times of 34 is 2 times of a, which is 68. Okay, further simplification, x is 680 plus minus what is 462400 minus 87856 and square root of answer, which is 612. Divide 68. Okay, now from here we have two x values with a positive and one with a negative. So we can take 680 plus 612, divide 68, which is 19, and 680 minus 612, divide 68, which is 1. So x is equals to 1. Okay, so we have two x values. Let me find the corresponding y values. So the equation of line L is y plus 9 would be equals to minus 5 over 3 into x minus 10. Right, now let me substitute both values of x one by one to get the y value. So y is equals to minus 5 by 3, 19 minus 10 minus 9. This is the first one. And y is equals to minus 5 by 3, 1 minus 10 minus 9. Okay, so 19 minus 10, okay, times minus 5 divides 3 and subtract 9, which is minus 24. 1 minus 10 times minus 5 divided by 3, subtract 9, which is 6. Right, so the two possible coordinates for S are at 19 we have minus 24, and for 1 we have 6. Right, so that was the last question of our paper. If you have any queries, please let me know in the comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.